Okay, and you have seen reversible process and irreversible process. Okay, so can anyone tell me what is one irreversible process? But we have seen many processes. Okay, Monshi, tell me what is the reversible process? Any process? Tell me.
Boiling the water.
Tell me process is enough.
Process.
Hmm.
First, if we boil the water, it will become vapor, and if we cool down the vapor, it will become again the water. And irradiation process is the fuel we are pouring into pipes, and we.
Yeah, there is a reversible and irreversible is we can apply the original state where we have started, and in some other cases it cannot be. So what are the different processes? Okay, we have given the definition. Give me some process. Tell me any one process. What you have known?
Isochoric.
Isochoric process. Okay, what is the other name for isochoric process?
Constant volume.
Constant volume. Okay. What is the significance of constant volume process? Ashik, please come. What is the significance of constant volume process?
Sir, significantly throughout the process, the volume will be same.
Very good. So what you have told is throughout the process volume is constant. What other thing what you want to say?
That's all.
So now we are going to deal with the constant volume process. Okay? We are going to deal with the constant volume process. Okay? Now, for understanding this constant volume process, we are taking a setup. Okay? Here we are having a small piston. Okay, here we are having some edges. So this is an piston. Okay. Inside this, we are taking a gas. Okay, here there is an gas. Here it has some mass. Okay, here has some mass. So it has some pressure, volume, temperature, like that. It has some properties. Okay, so this can be when heat is supplied. Okay, when heat is supplied to this system. Okay, what happens is it moves from state 1 to state. It moves from state 1 to state 2. So when this process is done, what we are assuming is we are assuming that volume is constant. Volume is constant. We are doing this process by keeping the volume as a constant. Okay. Now what will be the PV and TS diagram? Okay. If we go for the PV and TS diagram, so we are taking the P in the y-axis and volume in the x-axis. P is the pressure, V is the volume. Okay. So here I am fixing the first point here. Okay. I am fixing the first point here. That is state 1. Now you want to have a small puzzle. Okay. Anyone can answer for this. So how to represent the process of 1 to 2 in this graph? How the line should be drawn? The process is drawn by a small line. Is the how to the line, whether a vertical line or a horizontal line or a slanting line. Any idea? Slanting line. Why?
Sir, already
You are telling by reaching. Okay. I think it is not the correct answer. Any others can try?
The straight vertical line, sir.
Straight vertical line. Why?
So because the volume remains constant throughout the process, so only the pressure increases, sir.
Very good. We can give him a big hand. Okay. So what Dharmendra said is we have already put that it's a constant volume process. Okay. The value of this volume will not change. Here is a particular value for this. This is called as V1. What I told is the volume does not changes. So the line will be like this. So this is 1 to 2. The process is 1 to 2. Okay. Here this is P1. Here it is P2. Now here it is V1 and here it is V2. Because the volume will be the same value, but pressure will be different. So this is PV diagram. In the TS diagram, okay, the cross will be like this. This is 1 and this is 2. Here this is temperature, here this is entropy. If you take here, this is T1. If you take here, it is T2, and here it is S1, it is S2. Okay, so this is about the constant volume process. Thank you.